key terminologies in Kubernetes, right. So, the first one is pod. What is a pod, right? Pod is the smallest unit you can deploy in Kubernetes. Any entity you are deploying in the Kubernetes, okay, that is a pod, right. It wraps one or more containers that need to run together, sharing the same network and storage. So, basically when I have code and something along with it, I am converting into image. This image I am converting or I am putting in a container, right. This container is wrapped up, okay, right, and we put it in a pod. There is something called as pod. In pod we will be putting this container, right. So, pod is nothing but basically a container along with the image together can be kept inside a pod, another wrapper layer, you can understand. Pod is the smallest unit you can deploy in the Kubernetes. It wraps one or more containers that needs to run together, sharing the same network and storage. Containers inside a pod can easily communicate and work as a single unit. So, maybe you want to group C1, C7 and C9, you can group them and put in you can wrap them together, bundle them and put under a pod, convert it as a, we can call it as a pod. And because Kubernetes contains only pods and each pod contains lot of containers, one or more than one, right. So, this can communicate easily among each other inside a pod, right. So, next, node. What is a node in Kubernetes? Node is a machine, a physical machine in a Kubernetes cluster that runs your application. So, node is like a virtual machine, it is like a server where your containers are running or your applications are running. Each node contains the tools needed to run the pods, including the container runtime like Docker, the kubelet agent and the kube proxy. Okay. So, we will understand what is kubelet and kube proxy very soon. So, basically a node is something where you can run your pods. So, our pods will be running. When I am saying pod is running, inside it containers are running. So, whatever stuff is required to run the container also is included in the node. Now, if you see here, code plus this stuff, dependencies, I create image, this image I create a container, same way I may create a container C2, same way I may create a container C3. All this can be kept inside a pod. So, these three plus container runtime. So, something which is required to run these containers can be kept inside a pod and we will be running these pods. Okay. The health of the pod will be taken care, right. The third term is deployment. Deployment is basically a Kubernetes object used to manage a set of pods running your containerized applications. So, above container comes the term pod and deployment is an object where you are running your containerized applications. Okay. It provides declarative updates, meaning you tell Kubernetes what you want and it figures out how to get there. Okay. You can give instruction, it will tell what is the problem to solve it. Then the fourth one is replica set. A replica set ensures that the right number of identical ports are running. So, now for a microservice application, if let us say I have some 20 microservices, I will have 20 containers, basically 20 services into 20 containers. These 20 containers are grouped into some pods, P1, P2, P3, P4, maybe some P5. Here there are 6 containers, here 2, here 3, right, here some 7, here 1, like this we may have different pods. Okay. So, replica set ensures the right number of identical pods are running. So, sometimes when you want to balance the load, you may have a duplicate pod also running for you, P1 cap. So, the replica set takes care of that, right. The next terminology is cluster, the most important one, cluster. So, if you understand at least little concept of big data, Hadoop, we call everything as a cluster there, right. Functioning happens in the cluster. Okay. So, in a Kubernetes cluster is a group of computers called nodes. It means group of physical machines or group of virtual machines together forms a cluster that work together to run your containerized applications. So, where do you run your application? We need some physical machine, right? We need some physical machine or virtual machine. Only on those our application can run, right? A group of such physical or virtual machines together is called as a cluster. Okay. So, this is the most important component of the Kubernetes, right? So, the nodes can be either real or virtual ones. Okay. So, there are two types of nodes. One is master node, the control plane, the other is worker nodes. Okay. So, master node is like it will make decisions like where to run applications, it will handle scheduling, it will keep track of everything. Worker nodes are the actual machines that run our applications. Okay. So, each worker has a kubelet agent, a container runtime and tools for networking and monitoring. Basically, this is just a dummy agent, a dummy component. Actual job is taken care by the worker nodes, right. So, if you see the diagram or just a rough understanding of it, so you have lot of pods, right. Each of this, let us say P1, P2, P3, P4, let us say I have 4 pods. These 4 pods will be working in some virtual machine VM1, this also working in VM1, this is also working in VM2, this is in VM1. So, I have 2 virtual machines where I am running 4 different pods, right. This is one group. So, this is called as one cluster. Okay. So, in Kubernetes cluster we have 2 types of nodes. One is master. So, in between there will be one node VM3, let us say. So, this is the master node and these are the slave nodes or the worker nodes. So, this virtual machine takes the instruction and it gives the task to individual pods or individual machines, right. So, VM3 is just dummy, this is just a master. Actual application is running in the worker nodes, these 4 worker nodes the application is running, right. So, this is the another most important concept, cluster. So, we will again recall this once we study about the Kubernetes architecture, right. Then there is something called a service. A service in Kubernetes is a way to connect applications running inside your cluster. So, within a cluster, if I am having multiple applications running, multiple pods running, inside pod I may have multiple containers running. So, if they want to connect each other, we can use something called as service. It gives your pods a stable way to communicate, right. Then ingress is a way to manage external access to your services. See, your applications are running in a Kubernetes cluster. In Kubernetes cluster, I have lot of virtual machines. In each machine, I am running different pods. Inside pod, I am having multiple containers. So, if one service inside my pod, that inside my pod I have a container, there is my service running. If I want to access or talk to somebody external, right, I have to use ingress. It provides HTTP and HTTPS routing to your services, acting as reverse proxy, right. So, if you again understand this, I have one cluster. In cluster, I have so many virtual machines. I have one virtual machine M. In this, I have so many pods. In this pod, I have containers C1, C2 running, right. So, inside container, I am having the service running. So, it is as big as that, right. This is my cluster, and then I have inside this cluster, I have one virtual machine. Inside the virtual machine, I have so many pods. This is one pod. Inside this pod, I have container C1 and C3. Inside this container is my service running. So, if they want to talk to some external agents, I have to use ingress, right. And the next most important component or the terminology we will be accessing or understanding soon is config map. What is this config map? It stores configuration settings separately from the application. Okay. So, changes can be made without modifying the actual code. So, all the configurations related to the application are stored in the config map. Let us see an example. Imagine you are having an application that needs some settings like a database password or an API key. Instead of hard coding these details in your application, in your code, you can store them in the config map. So, during runtime, our application will access this config map and it will get the credentials from there, right. That is the purpose of the config map. Then a few more some simple important terminologies. Secret, there is one keyword secret. What is this secret? It is a way to store the sensitive information. Okay. Inside the Kubernetes cluster, I want to store some sensitive information, I call it as secret. Then persistent volume, volume basically is a piece of storage in the cluster where you can store your data, and it does not get deleted when a pod is removed or restarted. Okay, so all your data related to that application is stored inside the volume, persistent volume. Then kubelet, kubelet runs on each worker node and ensures that pods are running as expected. So, one more very important component in Kubernetes, or the frequently used term, is kubelet. Once we understand the Kubernetes architecture, we will be talking a lot about kubelet, right. It's inside worker nodes, there is something called kubelet, which will make sure that the pods are running properly, right. And the final one is kubeproxy. So, it manages the networking inside the cluster, ensuring different pods can communicate. So, pod 1 to pod 2 they have to communicate, then in that case we have to use kubeproxy, right. So, these are few important terminologies what we will be frequently talking when we talk about Kubernetes. The most important one is the cluster, right. So, if you once again understand this cluster, so let us say I have one container C1, which let us say I have one microservice 3, it is kept inside a container C2, that container is kept inside a pod P2. Okay. This pod is running in the virtual machine, let me write it outside, it is running in virtual machine 7. Okay. There is another virtual machine here, there is another virtual machine VM2, inside that there is one pod P7, inside this there is another container C3 where microservice 1 is running. So, maybe there is another pod P9, right, there is a container inside it and there is one microservices 11. So, this is the architecture. Now, basically these are all my services, MS3 is my microservice. Let us say I am having one web application where there is username and password, login screen is there. Once the user enters username password and clicks the submit button, okay, this is my microservice 3. The login screen which is exposing to me is microservice 3. From there I have to check in the database. So, this service will talk to this MS1, which is the service to validate the credentials, where this MS1 talks to MS11, because here I am connecting to database which stores my credentials, and then this gives a response back and this gives a response back. So, whether it is success or failure, this is how it communicates. So, virtual machine, one virtual machine can run multiple pods, or there can be multiple virtual machines depending on the load. So, within a virtual machine there can be multiple pods, and these multiple pods can talk to each other, and inside each pod I can have multiple containers C1, C3, C7, and each container contains only one microservice, right. So, this is the overall structure of the Kubernetes. Okay. So, we will see a different view of this Kubernetes while we study the master worker architecture or the Kubernetes component architecture, right. I believe you understood some important terminologies what we are going to use in Kubernetes.